Okay, so hopefully this won't crash my computer. I'm running all these recordings at the same time. Okay, so I'm going to give you some advice on your homework for 1.7. That starts on page 72. Okay, and so this is functions and their graphs. So I'll have another video to explain the functions and their graphs and their shifting and all that good stuff. But let's assume you've watched that video or you were in class and we discussed that. And then questions 21 through 45 are only asking A only. I just want you to identify the parent function. So you should be able to say that's either x squared, or that's absolute value of x, or that's x cubed is going to look like that. What else? There's the floor function that looks like this. There's little steps with barbells on the left hand side that are filled and open on the right hand side. Okay, so that's the floor function. Your book calls that the greatest integer function. And the square root function. Okay, so those are the only functions you need to be aware of for that exercise. Yep. Then the instructions say 27, 29, 30, all. Which what it means is the first 21 through 45, I just want you to identify the parent function, but I want you to do the whole exercise for 3 of them. Okay, so for 27, it's asking you for a parabola, and for 29, it's a square root, and for 30, it is another square root. So I'll show you a different parabola. Okay, so I'll just pick a different parabola function, like 28, because you don't have to do that one. So 28 is asking the student to graph and explain what's happening here. And luckily I have a computer that allows me to do this very nicely. So what it means is if I take x squared, okay, and let me just make it some other variable, t squared, just for make it a different letter. If I take that, what does t plus 2 squared look like? Okay, let me make it a different color. Well, it means I'm going to take this picture here. Alright, and I'm going to have another copy of it. Am I going to shift to the right or to the left? Which way is it going to go? It's going to go to the left. Why is that? Because when you change the input, you're going in the opposite direction as you might think. Right? So you're going to the left, and you should think of it this way. You should think of this plus 2 as telling you that you're kind of early. You're kind of doing a look ahead. You're looking ahead to see what happens at t squared, but you're peeking ahead 2 time units early. So that's why it seems to go in the opposite direction. But if you think about it as peek ahead, then it won't seem like it's early. Or it won't seem like it's backwards. Okay, then what happens? Well, then you're going to multiply by -1/4. Well, what does that do? Well, we're going to flip this, but I don't remember how to flip, so I'm going to just draw another copy of this, so I'm cheating a little bit. 1/4 is going to be like that. It's going to be upside down, and it's going to be kind of like that. So this is going to go now here, right about there. Okay, so this is what it looks like if it's going to be -1/4 x plus 2 squared. But then, alright, this is the one I wanted to copy now. This guy. Alright, this is the thing I want to copy. So I want to now be able to subtract 2, and I know you're not going to have trouble with that. So you just let that drop by about 2 units. And so finally this is going to look like minus 1/4 x plus 2 squared minus 2. Okay, so you start with the blue one, move to the red one, move to the green one, move to the orange one. And then of course, if you're doing your homework, here's what I recommend, is that you say, hey, I'm not 100% sure this is right. Let me just check on Wolfram Alpha, and if that's right, then I'll be convinced. Okay, I'm sorry it's taking so long for this to come up. Well, I guess you're on a video, you can fast forward if you need to. So this is, you want to ask it to plot, and you could do minus 1/4, but you can minus 0.25 if you want, that's fine. X plus 2 squared minus 2. And you can also specify which domain you want it to be in, but usually Wolfram Alpha will pick something reasonable. Then you can just look and see if your plot that you drew roughly agrees with what's going on. Okay, so it's telling me that my vertex is right around here at -2, and it's telling me I'm crossing the y-axis down here at -3. Maybe that's a good thing to know. But in any case, it's not contradicting what we're saying. So let's test to see if this is at 3. We already knew this was at -2. So if we put x is equal to 0 in, we get minus 1/4 times 4 minus 2, which is -3. So we're happy. Like, what we're doing is consistent with what Wolfram Alpha says we're doing. Okay, so that's how you handle, and the same thing with the square root. I mean, you just pop that thing around, right, left, up, down, squish it, do whatever you want, and then double check on Wolfram to make sure that what you've done makes sense. Okay, so that should get you through the first batch of 1.7 questions. And then there's one, number 56. What does 56 ask you to do? It says use the graph of x cubed, write an equation for each function whose graph is shown. Okay, so I'm not going to do this, but I will give you some hints for this, because I can't just do a nearby question, because this is kind of unique. Alright, so instead I will just, sorry about this, I will just give you some hints. And so the hint is, you should realize this cubic, there's something special about it. And these 3 points are very convenient. These 3 points make it very easy. These 3 points on y equals x cubed make it very easy to track what's going on. And so what the exercise is asking you to do is it's saying, hey, just visually, based on looking at the symmetry that appears to be in the diagram, we're telling you that this is the point 2, 2. Then you kind of know this is going to be -2, -2. Like, you know that just visually. They didn't explicitly say that, but you kind of need to know that. In other words, what you need to figure out is that the point that was here has now become here. So everything that happened, like if this is 1, 1, whatever happened here, the next point is going to be 2, 8. Where do you think it's going to go over here? Think about where that's going to go. So if the point 1, 1 gets stretched to 2, 2, that means the x magnified by a factor of 2 and the y magnified by a factor of 2, then this guy has to become 416, right? So this will help you figure out what's going on. So that's kind of the clue for that one. You can figure it out. But remember, this particular chapter is making use of the fact that we know how to stretch and shift and squish and everything like that. So it's specifically asking you to figure out what's going on in that situation. Okay, and what about the other one? The other little graph, they flip it the other way. Okay, so they're still leaving the origin alone, which is very nice, but they're saying 1, -2. So where did that point come from? You can think of it in more than one way, but I may as well just, like, you could, since this has symmetry, you can you can either imagine that this rotated or it flipped. It's probably easier to think that it flipped. So in other words, 1, 1 became 1, negative 2. Well then, where does something like 2, 8 go? Well, 2, 8 has to go to somewhere like, well, the x position stays the same, the y position multiplies by negative 2. So that's telling you how the transformation is going. That should be easier. Actually, part B is in some way easier than part A. Alright, and you may say, but what if in part A, instead of transforming the x and the y, what if I prefer to think of the following? And the following is perfectly valid. If you wanted to say, well, instead of 1, 1 is becoming 2, 2, what if I think that 2, 8 is becoming 2, 2. Okay, so in the old graph of x cubed and the new graph is what? And that's perfectly fine too. I don't care. You can make that assumption. Just draw it out carefully and be clear. Be clear. State your assumptions. And in some cases, it doesn't matter and you'll end up with the same final answer, and sometimes it will matter because they were a little bit sneaky with the way they wrote the assignment. They didn't really, sometimes they don't give you enough information to make a unique answer. If that's the case, then as long as you state your assumptions, then I'll follow your work and you'll get full credit. Okay? So that's your help for chapter 1.7.